Hi guys, welcome back to my channel again. I am Mr. Nakedi for those who don't know. So today we are doing introduction to trig for grade 11. This is just a mini video that you have to go through before we start with our examples and so forth of different concepts in trig. Now I just want to pick your brain up and remind you some of the stuff that you did in grade 10. The first thing that we are going to start with is our soccer tour, or if you want to be in a private school, they say, oh hell, another hour of algebra. Oh hell, another hour of algebra. That's another way if you want to remember this. Or you can simply just say soccer tour, straight and forward. The O, it's for opposite. S is for sin. O, it's opposite. And then this is the hypotenuse. This is cos, adjacent, hypotenuse, tangent, opposite, adjacent. Now, this is just reminding us that if I'm dealing with the sine of an angle, it's the opposite divided by the hypotenuse. And if I'm dealing with the cos of an angle, it's adjacent over the hypotenuse. The tan of an angle, it's opposite over adjacent. So that's basically that. Now, that will be the first one. But now, how do we get this opposite, this hypotenuse, this adjacent? Just to remind you, remember this only applies if your triangle, it's a right-angled triangle. You cannot apply soccer tour if your triangle is not a right-angled triangle. It only applies on triangles that are right-angled triangles. So yeah. So let's say I have a theta here, alpha here, beta here, and maybe x here. And then I ask you, what is the sine of x? Firstly, you ask yourself, what is sine? The sine of an angle, it's opposite over the hypotenuse. Now you go to sine, we want the opposite. All right? Okay, here's the catch now. Every time you have a 90-degree, a right angle triangle, you must always take out the hypotenuse, because that one, it's standard, doesn't change. Doesn't matter if you're at the bottom of the building or on top of the building, the hypotenuse is the hypotenuse. It's the side where your right angle is facing. But in terms of the opposite and adjacent, it depends. Are you at the top of the building or are you at the ground of the building? So the opposite will depend on what angle are you looking at. For an example, I'm looking at x, right? So it means this will be the opposite. And then this will be the adjacent. Let's put variables here to give it life. This is maybe 5, 4, 3, and then 5, 3, 4. All right. Or let me use another numbers here. Maybe 1, 1, root 2. Good. All right. Now it's opposite over hypotenuse. Now the opposite of x is going to be 4. The hypotenuse would be 5. And then the sine of beta. Now I'm at the top of the building. My opposite now will change to be 3, which is opposite over hypotenuse. The opposite is 3. The hypotenuse was 3 remain as 5. I hope I'm making you now. You're remembering now. And then the cos maybe of an alpha. The cos of an alpha, it's adjacent over hypotenuse. Where do I get that cos is adjacent over hypotenuse? I got it from my soccer tour there. That cos is opposite, it's a over h. Sine is o over h. Tan, it's o over a. Now, the cos of an alpha would be the adjacent now for this. It's next to, would be 1 over the root of 2. And then if I want the cos of theta, it's adjacent, which is also 1 over the root of 2. But this one, the one that is adjacent here, next to theta. Are we clear with that one? Yeah, so that is just the basic soccer tour that you need to know. If you're still not getting this, the opposite, adjacent, and what, you can try to check the grade 10 video that should be available, or it will be available at the later stage. All right, now we are done with the soccer tour. I want us to do the cast rule now. Let's do the cast rule. This is the main thing. Remember in grade 10, this was the main thing, like learning the opposite, the adjacent, and the what. Now, the cast rule is the main thing now in grade 11. You need to know the cast rule. Now, remember the cast. We are saying that in the first quadrant, all our trig ratios are positive. Sine is positive, cos is positive, tan is positive. In the second quadrant, which is S, this is first. Second quadrant, we are only saying that sine is positive. And then cos would be negative, tan will also be negative. And then in the third quadrant, sine is negative, cos is negative, but tangent is positive. You look at the alphabet of your cast. T means T is positive, S means S is positive, the A means all of them are positive. We go to the fourth quadrant. The fourth quadrant, sine is negative, cos is positive, and then tangent is negative. That is the first thing that you need to learn. All right. Now, after that, you need to know what's happening in those quadrants now. Let me just do it here so that we don't complicate our stuff. I'm still going to do my cast here. All right. There we go. We are saying that this is 0 degrees, 90 degrees, 180 degrees, 270, this is 360. We are saying this is the first quadrant, this is the second quadrant, this is the third, and then this is the fourth. Now we are saying all the angles that are less than 90, you find them in the first quadrant. Those that are bigger than 90, which will be 90 plus, are in the second, but they are less than 180. Then in the third is those that are bigger than 180, but they are less than 270. And then here we get 270 plus, those that are bigger than 270, but smaller than 360. And then all the angles that are bigger than 360, they fall in the first quadrant. All right, now this is what you are having. Remember, you still have your cast. Now it means 180 minus, I'm talking about quadrant number 2. 90 minus, I'm talking about quadrant 1. 180 plus, I'm talking about the third. 360 minus, I'm talking about the fourth quadrant. That's basically what I'm speaking about. All right. Now I want us to do this now. Let's have the sine of 180 minus the cos of 180 minus the tangent of 180 minus, and then the sine of 180 plus the cos of 180 plus, and then the tangent of 180 plus. And then we have the sine of 360 minus the cos of 360 minus the tangent of 360 minus, and then the sine of 360 plus the cos of 360 plus, and then the tangent of 360 plus. All right, now this is what I'm having. Someone is there sitting wondering, but why is Sir not putting in 90 or 270? Guys, 90 and 270, we don't like 90 and 270. We don't like. We just tolerate it because we don't have a choice. You know that just those things, all those people in your life that you just tolerate because you don't have a choice. Now we say that 180 and 360, this is our besties. This is our besties. We're just gonna use this most of the time. We'll use 90 and 270 when we don't have a choice, and I'll explain why to you at a later stage. Now, let's focus on our besties now. The sine of 180 minus theta, what does it say to us? It's telling me that 180 minus, I look at 180 minus, I find it there in the second quadrant. It means this question saying sine at second quadrant. How is sine in the second quadrant? Sine is positive. That's what the question is asking you. The cos of 180 minus is saying, how is cos at 180 minus? 180 minus is the second quadrant. How is cos there? Cos is negative. And then that one is saying, how is tan at 180 minus? How is tan in the second quadrant? We know that tan is negative. 180 plus, this is your third quadrant. This is literally your third quadrant. So the question is asking you, how is sine in the third quadrant? How is sine there? Sine is negative, so you have negative sine theta. The cos will also be negative cos theta, but we know that tan is positive at the third quadrant because of our cast rule. And then we go to this one. It says the sine of 360 minus theta. Which quadrant is 360 minus theta? It's the fourth. Here it's 360 minus theta. So do you see how important it is to have this rough sketch like when you write or you do your test, so that you just look, you don't want to think a lot about it. You look at the diagram, you check 360 minus, where do I find that? In my fourth quadrant. How is cos there? It means cos is positive, but how is sine there first? Sine will be negative. And then how is cos? The fourth quadrant, cos is positive. How is tan there? Tan is negative. So that will be your answer. Sine 360 plus, how is sine in the fourth quadrant? Oh no, the first. 360 plus is the first. Yes, I must look. 360 plus, how is sine there? It's positive. So this will be positive sine theta. How is cos there? This would be positive cos theta. How is tan there? This will be positive tan theta. So this is the main character in grade 11. You need to know this, but we are going to do an example as to, you will see how they ask this question, but I'll do those examples at maybe part 3 or part 4. I don't know. You just keep looking on the videos. All right. Now I want us to do negative angles. Negative angles. So all we have dealt with, it's the positive angles. All right, that's everything that we've dealt with. But I feel like if I could move to negative angles without dealing with the 90, we will have a problem. Let's deal. I know I said we don't like 90 and 270, but remember guys, we just have to tolerate it. We have to do it. So let's do it. So the sine of 90 minus the cos of 90 minus, and then the sine of 90 plus the cos of 90 plus, and then the sine of 270 minus the cos of 270 minus the cos of 270 plus, and then the sine of 270 plus. All right. Now let's talk about 90 and 270. This one, we call them to be our core functions. Remember 180 and 360, those are our besties. But this one, they are just core functions. Really nothing important. Nothing really to be interested in. Eh? So we try by all means to avoid them, but sometimes we just have to use them, tolerate them. We don't have a choice. Now, what is the sine of 90? And then someone is sitting there wondering, but sir, we wrote everything except for tan, because we don't have a tan of a cofunction. You don't deal with the tan of a cofunction because of, you'll see why. So we are saying that if it's a cofunction, the sine will become the cos will become the sine. But you keep note of the original question. Now the sine of 90 minus, let's go at 90 minus. 90 minus, it's the first quadrant. How is sine in the first quadrant? Sine is positive, but the answer would be the cos of theta. So the answer would change. So every time you're using 90 and 270, you must have something at the back of your head to know that they must change. Then the cos of 90 minus. Which quadrant is 90 minus? It's the first. How is cos there? Cos is positive. This will be positive, the sine of theta. The sine of 90 plus. 90 plus. Which quadrant is 90 plus? There's 90 plus. It's the second quadrant. The original question is saying sine. So we focus on the original question. It says the sine of 90 plus second quadrant. How is sine in the second quadrant? Sine is positive, but this will change to cos. Now, I've had a learner saying to me, but say cos in the second quadrant is negative. Then I asked the learner, was the original question asking you about cos or sine? And then it was sine. So we focus on sine, but just that it will change to cos. I hope I'm making sense. And then 90 plus, the cos of 90 plus second quadrant, how is cos there? Cos is negative, but this will be sine theta. Remember, it's changing. It's changing to sine. All right, sine 270 minus is which quadrant? 270, it's the third. Now 270 minus is the third quadrant. How is sine there? Sine is negative, but this will be cos. The cos is the third quadrant. 270 minus the third quadrant. How is cos there? Is minus, but it will change to sine. The cos of 270 plus, it's in the fourth quadrant. How is cos there in the fourth quadrant? Cos is positive, but it will change to sine. Remember, the original question is asking you about cos, not sine. So you look at 270 plus and the question, the fourth quadrant question is cos, so it's positive, but it will change to sine. The sine of 270 plus, this is the fourth quadrant, but this will change to cos. All right. Now that's your cofunctions, guys. You see what I told you guys about? Yes, correct. Now we go to our negative angles now. And let's do a bit. There will be also a video just solving sums with negative angles. But let's do basic ones for now. Cos of negative, and then the sine of a negative, and then maybe sine negative. All right, now let's have a look there. Every time I have a negative angle, now if I have negative angle, I always add 360 degrees to it. You add 360. You see a negative angle, go straight and add 360. So I'm going to go there at 360, add 360, add 360. Now this will be the sine of 360 minus theta. This will be the cos of 360 minus theta. This will be the tan of 360 minus theta. So it's basically the fourth quadrant. How is sine in the fourth quadrant? Sine is negative. This will be negative sine theta. How is cos in the fourth quadrant? It's positive. Then how is tan in the fourth quadrant is negative. All right. And then we continue. We look at negative sine theta plus 180. Look at that 180. It's not negative. It's positive. So this is just the order. Do you see the order they wrote this? Like you could literally just swap them. This will be 180 minus theta. Which quadrant is that? Is the second. And how is sine? The sine is positive. So this will be positive sine theta. The cos of this, it's negative 180. You see negative 180, negative 90, negative 270, negative 360. That is a negative angle. You add 360 to it. You add 360 to it. You add 360. Now, when we add 360 here, I'll have the sine of minus 180 plus 360. This will be 180 minus this. Oh, sorry, the question is cos. So this will be the cos of 180 minus theta. Second quadrant and cos is negative. Go to the third one, you add 360, this will be the sine of 180 minus theta. Second quadrant and sine is positive. That will be your answer. And minus 270 plus 360, I think it's 90. Yes, it's 90. So this is going to be the cos of 90 plus theta. 90 plus theta is which quadrant? Is the second. How is cos there? It's negative, but it's a cofunction. It will change to sine. I will clear and say. So these are your negative angles. All right. Now we've dealt with negative angles. We've dealt with normal angles. I want us to deal with in a Cartesian plane again, because we're still in our cast. Let me put it with those other cast. Alright, I should have done this here. I have x, you have y. Now it's important to understand that in the first quadrant, x is positive and y is positive. And then in the second quadrant, y is positive, x is negative. In the third quadrant, both x and y are negative. On the fourth quadrant, x is positive, y is negative. This is one of the things that are important, because we're going to be dealing with a question that needs you to know that in the second quadrant, y is positive, sine is negative. In the fourth quadrant, x is positive, y is negative. All right. Now let's do our special triangles now. Let's do our special triangles. Okay, let me start it from the beginning, where it comes from. Remember, it comes from an equilateral, and then the other one comes from a square. All right, perfect. And this is 60, 60, 60, then 2, 2, 2. So what we did is we cut this into 2, then we form a 90-degree angle. So this is where the first special triangle is coming from. All right. This is 90. This is 2. This is still 60. When I cut 16 to half there, we get 30. 2 into half, 1, 1. So this will be 1. Use Pythagoras, you get the root of 3 for that side. And then here it was a square with all the 90s. Both sides each equals to 1. So we cut it into half as well. And then this is what we got at the end. And then this was 1, 1. Then 45, 45. You use a Pythagoras. You solve that, you get the root of 2. Alright. Now, let's do the sine of 60. The sine of 60, remember the sine of an angle? Oh hell. Another hour of algebra. So it's oh hell. Alright. Now opposite, it's the root of 3 divided by 2. And then I want us to do the cos of 30. Cos of 30, it's here. Cos of 30, it's adjacent over hypotenuse. What is the adjacent of 30? It's the root of 3 over 2. And then the sine of 30, it's opposite over hypotenuse, which is 1 over 2. The cos of 30, it's adjacent over hypotenuse. I must do the cos of 60. The cos of 60 is adjacent, which is 1 over 2. And then the sine of 45. What is the sine of 45? Opposite over hypotenuse is 1 over the root of 2, which is root 2 over 2. The cos of 45, which is 1 over root 2 as well, which is root 2 over 2. Now, remember guys, now you don't really need to know this triangle because you can just punch this in your calculator. But I mean, to know them as well, it's a bonus. You're a mathematician after all. All right, but you can always use your calculator. All right, now this is the answer that I'm getting. So I'm trying to bring you to something. Look at the sine of 60, the cos of 30, the sine of 30, the sine of 60, the sine of 45, the cos of 45. Look at those angles. Just give a look at those angles. Try to add them, try to subtract them, multiply, check if you're not getting anything common. I'm just going to give you a second. Oh, actually, pause a bit and think about it. Have self-control and just pause the video and think about it. All right. Now, when we look at 60 plus 30 is 90, 30 plus 60 is 90, 45 plus 45 is 90. What does it say? It means those angles are complementary. So if two angles are complementary, one is the sine of 20, and then the other one is the cos of 70. These are complementary. It means they are equal. Meaning the sine of 10 degrees will be the same as the cos of 80. All right, and then what else? Maybe the sine of 75 equals to the cos of how much? How much will they be? 15. Yes, this will be the cos of 15. Why? Because of two of these, they add up to 90. Like here, and also like there. All right, so those are special triangles. We can also do, for tan, there isn't much about tan, guys. You know, tan and 90, they don't match like that. So the tan of 30, for an example, it's of algebra, which is OA. 30, you go to 30, opposite is 1, adjacent is the root of 3. But like I mentioned, guys, you can always use your calculator with that regard. Yes. And then I think from my side, in terms of introduction, this is where I'm going to end the video. I think I've explained everything that needed you to know as a brief, because when we do the examples that are starting on the next video, when we start with the examples, you are going to need all this information. You need to know this. So take your practice book, make your notes. They must look nice like mine, like that. You see that. Make your own notes, practice, and then when we do the first example, follow the example just like that, each one of them. And then I'll try to have one video at least every day of trig until we are done with grade 11 trig, because it's quite a big topic in grade 11, and also continuous to your grade 12. Thank you guys so much. Don't forget to like, comment, and subscribe. Just leave some love there in the comment section. Thank you. Bye.